Okay, whenever we will talk about atomic weight, so it is Mendeleev's periodic law. Okay, atomic weight की जब बात होगी तो it is Mendeleev's periodic law. And when we'll talk abhi modern periodic law, so the modern periodic law will say that the physical and chemical properties of elements are periodic function of their atomic masses. Sorry, atomic number. ठीक है, तो atomic number की जब बात होगी, so it is the modern periodic law. ठीक है, let us start with the modern periodic table. So when Mendeleev developed the periodic table, so when he was developing the periodic table, so उस time the internal structure of atom was not at all known. Okay, he did not know anything about the sum of about atomic particles. ठीक है, तो he only knew about atomic weight. तो उन्होंने atomic weight के basis पे he classified the element. But when the subatomic particles were discovered, so there was a scientist named Henry Moseley. Okay, there who discovered the modern periodic table. What did he do? He plotted a graph between a graph plot. He plotted a graph between frequency, this frequency and atomic number. Okay, what did he do? He plotted the graph between frequency and atomic number. Atomic number means Z. Okay, and he got a straight line. What did he do? He passed X-ray spectra. He took X-ray spectra of different elements and plotted a graph between frequency. Plotted a graph between frequency and atomic number and got a straight line. Okay, when he did the same thing between the frequency and atomic weight, जिसको we say atomic mass, तो he did not get the straight line. ठीक, तो अब इससे ये मालूम पड़ता है, इससे he concluded that he gave the modern periodic law and he said physical and chemical properties are a periodic function of their atomic numbers, not atomic mass. ठीक, so why did he do that? When Mendeleev was classifying the element, that time he did not know anything about the subatomic particles. क्योंकि उस time तक subatomic particles were not discovered. But as subatomic particle discovered, as we knew about the neutron and proton and electron, and we got to know something about atomic number, so Moseley he took a spectra of different elements. He took spectra of different elements, and what did he do? He plotted a graph. Okay. Achha, he plotted both the graphs between atomic masses also and between atomic number also. So he got straight line in atomic. He got straight line in atomic number and did not get a straight line in atomic mass. So from that he concluded that the chemical and physical properties are a periodic function of their atomic number, not mass. Okay? So how did he conclude that? By plotting graphs between atomic number and frequency. Okay? Okay. Then the modern periodic law also revealed analogy between 91 elements that were occurring there. Okay, उस time whatever 91 elements that was discovered, that was true for all the elements. Okay, also he said that also it also revealed some important analogies. What were the different analogies? जैसे कि एक ore of there is an ore of uranium and the neptunium, plutonium. There were elements in neptunium and plutonium and actinium and protoactinium. ठीक है, 4 elements की बात हो रही है. Neptunium, plutonium, actinium and protoactinium. They were found in the ore of uranium also. ठीक है, तो modern periodic law की वजह से we got to know this thing. And also by this modern periodic law, researchers were also motivated to do more research. In organic chemistry के जो researchers थे, they were also motivated to do more research to find out new elements. ठीक है, to find out new artificial elements. So these were the like modern periodic law आने के बाद these were the effect of that law. अच्छा ठीक है, और क्या पढ़ते हैं modern periodic law के बारे में? अच्छा, you also know that atomic number किसके equal था? Atomic number was equal to the nuclear charge, मतलब that was equal to the number of protons, right? Or you can say number of electrons for a neutral atom. ठीक है, what were we saying? I'm saying कि अभी in the last chapter what we have studied, that Z is equals to the number of protons, or you can say Z equals to number of electron for neutral atom, right? Acha. So it is easy now, since we know this, so we can easily relate the quantum number thing to the periodic table. ठीक है, अब since we know कि जो atomic number है that we is related to the number of protons and electrons, so we can easily relate the quantum numbers which we have studied in the atomic structure chapters with the periodic table. अभी कैसे we will relate? अभी when we will study about the groups and the periods, then I'll make you relate कि quantum number से कैसे we are related to the periodic table. ठीक है, अच्छा. It is now recognized that the periodic law is essentially the consequence of periodic variation in the electronic configuration which determine the physical and chemical properties of the compound. ठीक है, अच्छा. By the modern periodic law, now it at present time it is also proved that when we do electronic configuration, so the electronic configuration that we do also follows the modern periodic law. ठीक है, तो अभी तक कोई भी इस what it's is trying to say, the NCERT is trying to say कि अभी तक modern periodic law में कोई भी गलती हमें मिली नहीं है. ठीक है, we have not got any flaw, anything that can go against the modern periodic law. ठीक है, so it is what the NCERT is trying to say. Okay. Now, numerous forms of periodic table have been devised from time to time. अच्छा, when Henry Moseley gave the periodic table, so उस वक्त से अभी तक there are several forms of periodic table. ठीक है, so एक long form of periodic table आई, कुछ some came on the basis of chemical reaction, some came on the basis of valence shell electron, some stressed on the electronic configuration. ठीक है, so the today that we are accepting, that is called long form of the periodic table, that is the most convenient and widely used. ठीक है, अच्छा. Since though this modern periodic table was given by Henry Moseley, but अभी भी इसको मेंडलीव के लिए ही कहा जाता है, to honor him, because he gave the way to characterize all the elements. अच्छा, now modern periodic table की बात करते हैं, what we study today. So in this modern periodic table we have rows means horizontal rows, जिसको these are rows, and Mendeleev called them series. ठीक है, what did Mendeleev call them? Mendeleev ने अपनी periodic table में इसको बोला था series. Okay, and we have vertical columns जिसको we call them groups. ठीक है, rows को we call period and vertical columns को we call group. ठीक है, so rows are called as period and vertical columns are called as group. Okay, got it? Clear? Yes, ma'am. Okay, so up to here we are clear. ठीक है, now let me show you the periodic table. See, this is a periodic table. इसमें we have rows and we have columns. So this is group. ये vertical वाले कहलाते हैं group. These are called groups and these are called periods. ठीक है, the green ones are called periods. ठीक है, so we are clear with groups and periods. Don't get confused. सीधे वाले are groups and horizontal ones are periods. ठीक है, अच्छा. पहले क्या था? पहले भी it was classified as 1A, 2A, 3A and 4A. The पहले जो classification था, it was done like that. But today IUPAC, what is IUPAC? International Union of Pure and Applied Chemistry. What does it do? ये सारे rules बनाती है chemistry के, ठीक है? It makes all the rules. So what this union has done, it has said that rather than 1A, 2A, 3A, we'll have groups like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Rather than having 1A, 2A, 3A, 4A, 8B, 0 groups, we are having groups like group 1, group 2, group 3, group 4, like this. Okay. Also, what it has this thing done, it is also saying that we have 7 periods. So we have 18 groups. We have 18 groups and we have 7 periods. ठीक है देखो 1 2 3 4 5 6 7. We have 18 groups and 7 periods. ठीक है. Also there is also one thing कि the first period contains 2 elements, hydrogen and helium. Then second and third contains 8 elements. Okay. Then we have 32, 32, 32 and 32. Sorry. Then we have 18, 18 and 32 and 32. ओके ये कैसे आ रहा है अगर इफ यू रिमेंबर तो हम लोग जब इलेक्ट्रॉनिक इफ वी डू इलेक्ट्रॉनिक कॉन्फ़िगरेशन तो वी डू लाइक दिस ओनली ना 2 8 8 18 18 32 like this तो ऐसे ही now see quantum number is relating with the periodic table so how is periodic table defined the first period has 2 elements then we have 8 8 then we have 18 18 and then we have 32 and 32 now when this thing was when this book was written तो seventh period में this seventh period इसमें all the elements was not discovered so NCERT says that seventh period is still incomplete but we know now it is complete also there when you see periodic table so there are some elements which are written apart periodic table से अलग लिखे गए हैं separate panels में why to maintain the you can say symmetry of periodic table. To maintain the symmetry of periodic table, these 18 elements are written outside the periodic table. इसका कोई special meaning नहीं है, but to maintain the symmetry, actinoids and lanthanoids are written outside and placed below. ठीक है? But though they contain the sixth and seventh period contain 32 and 32 elements. Okay. Are we clear up to here? यहाँ तक there were only theoretical topics. यहाँ तक we have studied the modern periodic law, the Mendeleev's periodic law. We have also studied about the modern periodic table. कि we have 7 periods. We have 18 groups, and the first group contains 2 elements. Then we have second and third groups. Second and third period which contains 8 and 8 elements. Then fourth and fifth contains 18, 18, and then we have sixth and seventh that contains 32 elements respectively. Now, for group 6, for period number 6 and period number 7, we have lanthanoid and actinoid series which are placed separately below the periodic table to maintain the symmetry of the periodic table. Okay. These was all about the you can say development कैसे development हुआ modern periodic table का this was all about. Now इसके बाद what we'll study इसके बाद we'll study nomenclature. ठीक है, give me a minute, we'll start in a minute. Yes. So after this, what the topic is there? See, we have elements which whose atomic number is greater than 80, greater than 100, right? Acha. Also, these elements are अभी discover होंगे ये. These elements are discovered by some scientists. Now, what happens is क्या होता है कि all the scientists try to discover the elements and they try to name the elements by their country or their names itself. So in order to avoid these type of confusion and these type of you can say arguments, IUPAC what IUPAC has done, it has maintained, it has you can say given out some rules. ठीक है, तो what IUPAC has done, it said that IUPAC said that I am making some rules जब तक it is not confirmed कि which country or which scientist has discovered this element तब तक we'll name the element as per these rules. ठीक है, क्यों किया था? क्योंकि ऐसा हुआ था कि 104 एटॉमिक नंबर 104 वाला जो एलिमेंट था, दो अमेरिकन और सोवियत साइंटिस्ट दोनों ने they were taking the credit for discovery for that element. ठीक है, so Americans called it Rutherfordium and Soviet scientists called it कर्चेटोवियम, ठीक है, टू डिफरेंट साइंटिस्ट कंट्री के थे एंड दे ट्राइड टू गिव द नेम अकॉर्डिंग टू देमसेल्फ. To avoid such problem, what did IUPAC done? IUPAC has recommended some rules, and the IUPAC said that until and unless it is confirmed कि which country has discovered this element, I am giving you all guys some rules. Follow these rules and name the element according to these rules only. ठीक है, कैसे होता है? तो there are three things. दो चीजें होंगी, देखो 100 से अबव होगा तो देयर विल बी 3 डिजिट्स, फॉर एग्जांपल ए बी सी, ठीक है. तो ए के लिए ए का जो नंबर होगा इट विल बी 1 to 9, राइट, and it will be 0 to 9 and it will be 0 to 9. So what C वाला, C के लिए क्या होगा? C के लिए there is a fixed thing. So for A and B, for example, if we are given like 115 or 116, so for every digit, IUPAC has given some nomenclature. Is in organic chemistry, in class 10th, you might have studied some nomenclature. If you have not studied, you will study in this class. So for that, IUPAC has given nomenclature. क्या nomenclature है? See this. देखो, if we are going from 101 से हम आगे बढ़ रहे हैं, greater than 100 के लिए है this, okay, greater than 100, so we'll have numbers from 0 to 9, right? तो 0 1 2 3 4 5 6 7 8 9, ठीक है. क्या कहा गया है? For 0 it is nil, okay, for 1 it is un, for 2 it is bi, for 3 it is tri, for 4 it is quad, for 5 it is pent, 6 के लिए क्या होगा? Hex, then sept, then oct, and then n, ठीक है. Also we have abbreviation. nil के लिए n, u, b, t, q, p, h, s, o, and e. So these are the abbreviations and this is the name. अब कैसे इसको यूज करना है, let us see. अच्छा, so see, we will have 3 digits, right? तो 3 digits का नाम, first 2 digits will be given name by this, ठीक है, and at last we'll add IUM, we'll add the root and we'll add IUM, ठीक है. For example, कैसे समझ में आएगा? Let us see 101. So for 1 it will be un, for 0 it will be nil, un, nil, and then again un, nil, un, IUM, ठीक है. तो 101 का नाम क्या हो गया? un, nil, un, nil. कैसे इसको रिप्रेजेंट करेंगे? फॉर अन इट वाज यू, फॉर नील इट वाज एन, एंड फॉर अन अगेन इट इज यू. तो यू एंड यू, फॉर 101 द नेम विल बी यू एंड यू, ठीक है. सो IUPAC नेम according to the nomenclature for 101 is U and U, but since it is now discovered और इसका नाम भी दे दिया गया है, the official name of this 101 is Mendelevium, ठीक है. So do you understand the nomenclature or do I need to explain again? Abhi I am not explaining with example. Abhi I am only telling you the nomenclature. Abhi I take 2, 3, 4 examples. Then you will get to know more easily.
This means like I understood.
Okay. For example, if I am talking about 115, so 1 के लिए what I'll use? Un. Again 1 के लिए I'll use un, and 5 I'll use pen. So unpent, and at the last I have to use IUM. So what will be the nomenclature for this? UUP. ठीक है, for 115. Unpentium. ठीक. अब इसका this is the nomenclature name. Then what is the original name? What is the IUPAC name? Official name? It is Dubnium. DB. DB. ठीक है. Okay. No one has shown it. So this is the nomenclature for atomic number greater than 100. Got it? Okay, now tell me one. I'm asking. Tell me the nomenclature for 1, 1, 2. Okay, if you don't want to spell it out, yeah, you don't want to read it out, you can write in the chat box.
on my side.
Yes, done. What did it, okay, you have written un, very good. So I think you are clear with the nomenclature, right? Yes.
Yes, ma'am.
So whenever a new element is discovered, first it gets a temporary name which IUPAC has given, and after when it is confirmed ki which country has discovered it, it is given a name according to that whatever that country says. Okay? It might represent a country, or it might represent a scientist name to give him a contribution. Okay? Now elements with atomic numbers 118 has been discovered, and official name also have been given to them. Okay? Now for if any element discovered as अभी तक 118 has element had discovered. Now if 120th element comes, what will give its name? Un, by, nil, IUM. Okay? So un, by, nilium. What will be its symbol? For un, you will use U. For by, you will be using B, and for nil, be using N. So U, B, N will be its symbol, and un, by, nilam will be its IUPAC name. Okay. Okay. Next topic which we have to study is electronic configuration of elements and the periodic table. Now, how is the electronic configuration of element is in the periodic table? How it is related with the atomic? How it is related with the quantum number which we have studied? We'll study in this thing, in this topic. Okay. So in the preceding unit, we have learned that electron is characterized by a set of 4 quantum numbers. जिसमें principal quantum number n defines the level of defines the energy level and known as shell. Okay. And the we have also studied how electrons are filled into the subshell. Yeah, SPDF में how electrons are filled. Okay. The filling of electron in SPDF was known as electronic configuration. Now we'll relate the electronic configuration with the arrangement of element in the periodic table. कैसे? Let us see. The period indicates the value of n for the outermost shell. See, अगर हम जाएं, if we go to the periodic table here, तो period की बात करें, if we are talking about period, so these are the periods, you will see कि इसमें एक चीज common होगा, the n, right? So the period indicates second period में जो भी n की value होगी, that will be the period number. ठीक है? Uh, if you do electronic configuration, for example, if I'm doing the electronic configuration of lithium, so I'll do 1s2 2s1. ठीक है? Electronic configuration of carbon 1s2 2s2 2p 6 होगा ना 2. See, I can see that n की value, if I am taking any element from the second period, सब में n की value is 2 only, right? Let us see oxygen also. Oxygen का भी देख लेते हैं. Oxygen के atomic number is 8, 1s2 2s2 2p4. See, if I take any element from the second periodic table, सबका n is 2 only. उसी की तरह if I take any element from, for example, from fourth period, atomic number 19, I'll see 1s2 2s2 2p6 3s1. 3s2 okay, 3s2 3p6 4s1 6 7 8 9 10 6 16 17 18 19. See, if I take any element from the fourth period, you'll say कि n की value is 4, right? So I can now, from these examples, by seeing this example, I can say whatever is the number of the period, that is the number of the principal quantum number, right? So, या उससे उल्टा कह सकते हो, whatever is the principal quantum number of the element, that its respective period, right? Okay, so so now what I'll do is I'll explain you something. Ki this it can be seen. Yeah, it can be seen that the number of elements in each period is twice the number of atomic orbital present in it. For example, n में n is equals to 1 है, ठीक है, n is equals to 1 है. So what is the elements? How many elements are there? 2 elements are there, ठीक है. n is equals to 2 है, तो 1 2 8 elements हैं. So जितने इसमें atomic orbital हैं, then twice the number of elements are present, right? ठीक है. For example, first period n is equals to 1 starts with the filling of lowest 1s orbital, and therefore hydrogen has it has two elements, hydrogen and helium, right? First shell में k is complete. Similarly, when we'll go from n, for n is equals to 2, it will start with lithium and it will end at neon, ठीक है. The next element is beryllium, then we have boron, and we have carbon, nitrogen, oxygen, fluorine, neon, ठीक. इलेक्ट्रॉनिक कॉन्फ़िगरेशन कैसे होगा? 1s2 हो जाएगा, 2s2 हो जाएगा, देन 2p आएगा, 2p 1 2s 2s देन 2p 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 2p, राइट? ठीक है. तो अगर इफ आई से कि व्हाट इज द रेंज ऑफ पीरियड, पहली पीरियड के लिए क्या होगा? 1s
Yes, ma'am.
1 या 2. ओके. फॉर सेकंड पीरियड इट विल बी 1s 1s2 and 2 1s2 2s1 to 2 and 2p0 to तो कितने आ सकते हैं? 6. 2p0 to 6. So if I am saying, I can add this one page. See, if I am saying what is the range for first period, period 1 के लिए, if I write general electronic configuration, I can say it will range from 1s1 to 1s2, right? Hydrogen and helium. If I'm saying the same thing for period 2, I can say 1s 2 to hoga hi, it will be same for all. 2s 1 to 2 आएगा, obviously. Also it can also range 0 to 6, right? So period 2 में we have helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now see their electronic configuration. If I say for lithium, I can say, if I do the electronic configuration, 1s2 2s1 1s2 2s2 1s2 2s2 2p1, right? यहाँ पे it will come 2p2, यहाँ पे 2p3 2p4 2p5 2p6. So see, we also have 1s1, we also have 1s2, we also have 2p0. देखो यहाँ पे these two are 2p0, and also we have 2p1 to 2p6. ठीक है. So I can say second period का general electronic configuration is 1s2 2s1 to 2 2p0 to 6. ठीक है. Similarly for period 3, if I say the general electronic configuration, period 3 के लिए what will be the general electronic configuration? 1s2 2s2 2p6, again 3s1 to 2 and 3p0 to 6. ठीक है. Why? Because the third electron enters in 2s orbital, ठीक है, and sorry, the third electron enters in the 3s orbital, and it will start at sodium and end at having 3p6 at argon, ठीक है. So this is uh, the general electronic configuration for period number 3, right? So इसमें 8 electrons थे, इसमें 8 electrons थे. This was the general electronic configuration. Now as we'll move to period number 4, यहाँ पे 10 elements और आ जाएंगे, right? Now period number 4 will contain 18. Period number 4 will contain 18 elements, right? Period number will third will
Yes, ma'am.
okay. Now period number 18 will contain, sorry, period number 3 will contain 18 elements. अच्छा, इसका जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या होगा? सी, नाउ सिंस वी आर मूविंग, हमने 3p फिल कर लिया, ठीक है। सो आफ्टर 3p which electron will be added? 4s will be added, right? So in the fourth period you will see that sodium will have, sorry, potassium will have 4s2, calcium will have 4s2, right? पोटेशियम के पास 4s1 होगा, कैल्शियम के पास 4s2 होगा, ठीक है। नाउ एज वील मूव टू स्कैंडियम, द इलेक्ट्रॉन rather than going to 4p, first 3d will be filled. ये we have studied in the last chapter कि why 3d will be filled, right? Do I need to explain here again कि why 3d will be filled first rather than 4p? Sam, can you hear me?
Yes, ma'am.
Do I need to explain why 3D will be filled? If you know, so you will tell me the answer in the next class कि why 3D will be filled rather than filling 4P, ठीक है। 4S के बाद 4P fill होना था, but in this why 3D is filling. This is your homework. Try find
Ma'am,
this answer. Read the previous chapter and find the answer and tell me. Okay, in the next class. Okay. Now moving to the period number 4, we'll
to
see
fill
if we
the
do the yes.
just to fill the electron half filled because half fully stable.
No, वो तो कॉपर और उसमें होता है. No, that's not the reason. The reason is कि 3D orbital is, the filling of 3D orbital is energetically more favorable. ठीक है, there less energy will be required to fill 3D rather than 4P, इसीलिए पहले 3D fill होता है, ठीक. Now let us see the electronic configuration of potassium, calcium, and scandium. Let us see. We'll move to period number 4. We'll have K, Ca, Sc, scandium, titanium, vanadium. Okay. Now see, I'm not writing a whole thing. Calcium, it is 9. The atomic number is 19, 20, 21, 22, 23. See, let us do the electronic configuration. यहाँ तक इसको ऐसे रख देते हैं नियोन. आगे बढ़ते हैं. नियोन के बाद आएगा 4s1. सी पीरियड नंबर 4, द प्रिंसिपल क्वांटम नंबर 4. अगेन 4s2. यहाँ पे आफ्टर 4 you'll see that it will be 3d1 4s2. सी प्रिंसिपल क्वांटम नंबर कौन सा होगा? हाईएस्ट वाला इज अगेन 4 ओनली. यहाँ से क्या इंडिकेट हो रहा है? दैट दिस पर्टिकुलर एलिमेंट बिलोंग्स टू द पीरियड नंबर 4, ठीक है. 4s2. again 3d2 4s2, 3d3 4s2, ठीक है. So what can I write? The general electronic configuration for period number 4 will be neon 4s1 to 2 and 3d0 to 10. Okay, so this is the general electronic configuration for period number 4. Okay. Clear, Sam?
Yes, ma'am.
Yes. Now these are called transition elements, okay. Because the energy, the 3D orbitals are before the 4p orbitals, 3D orbitals are filled, so these are called transition elements, okay. Now, then after 4p, we'll come across the fifth period, which will begin from rubidium, and it will be similar to the fifth. It will be similar to the fourth period only, but अब यहाँ पे क्या हो जाएगा? यहाँ पे हो जाएगा 5s1 to 2 and 4d0 to 10, ठीक है. सब सिमिलर होगा, only principal quantum number will change, ठीक. तो 4, see, period number 1 was different. Period number 2 and 3 was similar, 18, 18. Period number 4 and 5 will be similar. Sorry, 2 and 3, 8, 8. Period number 4 and 5, 18, 18. And then when we'll study 6 and 7, they will be similar, 32, 32. Okay? So जहाँ पे ये डी आ रहे हैं डी ब्लॉक वाले, दे आर कॉल्ड ट्रांजिशन एलिमेंट्स, ठीक है। अगेन भी हमने पढ़ा फिफ्थ पीरियड। देन मूविंग टू सिक्स पीरियड, सिक्स पीरियड में n इज इक्वल्स टू n विल बी, n जो प्रिंसिपल क्वांटम नंबर होगा, इट विल बी 6, ठीक है, एंड इट विल कंटेन 32 एलिमेंट्स थ्योरेटिकली। थ्योरेटिकली मतलब अभी जो हम लोग पढ़ के आ रहे हैं ना, अकॉर्डिंग टू द प्रिंसिपल क्वांटम नंबर 8 2 8 8 18 18 32 32, so it should contain 32 elements, ठीक है। तो सिक्स्थ में तो होते हैं 32, बट सेवेंथ में it was not filled. अच्छा, also why are these elements placed beside below the periodic table? To maintain the symmetry of the periodic table, ठीक है। इनको actinoids कहते हैं, these are called actinoids, the green one and the red one are called lanthanoids, ठीक है। they are placed below the periodic table to maintain the symmetry, ठीक। ओके, नाउ अब सिंस अब यहाँ पे आ जाएगा f, ठीक, y कैसे f आ जाएगा, 6 आएगा तो प्रिंसिपल क्वांटम नंबर में 6, ठीक है, प्रिंसिपल क्वांटम नंबर 6 होगा। सो द इलेक्ट्रॉनिक कॉन्फ़िगरेशन व्हाट यू विल सी इज, यू विल सी xenon, ठीक है। xenon के बाद यू विल सी इसको अगर अरेंज करो 4f 5d 6s and 6p, ठीक है। यू विल सी इलेक्ट्रॉनिक कॉन्फ़िगरेशन लाइक दिस। कैसे होगा, ऐसे होगा, पहले फिल होगा 6s, ठीक है। आफ्टर 6s, आफ्टर 6s व्हाट विल बी फिल्ड, व्हाट विल बी फिल्ड आफ्टर 6s, 5d फिल होगा, 5d के बाद 6p फिल होगा, देन 4f विल बी फिल्ड, ठीक है। सो ड्यू टू द 4f they are called inner transition elements, okay, ठीक है। it will start as lanthanum and it will end at cesium पे start होगा and it will कहाँ गया, we were talking about sixth period की बात करते हैं, yes, sixth period will contain 32 elements and the filling of electron will occur in this manner, ठीक है। ये how is filling of electron occurring, ये मैंने आपको पिछले चैप्टर में पढ़ा दिया है। it will start at cerium and end at lutetium, ठीक है, lutetium पे end हो जाएगा, got it। these are called inner transition elements, इनको lanthanoid series कहते हैं, ठीक है, जो 32 elements नीचे प्लेस किए गए हैं, okay। then we have actinoid series, actinoid series में अच्छा, lanthanoid series में there are सेवेंथ पीरियड में देयर आर रेडियो एक्टिव एलिमेंट्स, ठीक। सिक्स पीरियड में तो हमने पढ़ लिया देयर आर लैंथेनॉइड सीरीज। देन एज विल मूव टू n इज इक्वल्स टू 7, इट इज सिमिलर टू सिक्स पीरियड ओनली, उसमें भी 18 एलिमेंट्स आर प्लेस्ड बिलो द पीरियोडिक टेबल, और इसमें बस क्या होगा, प्रिंसिपल क्वांटम नंबर चेंज हो जाएगा, ठीक है। यहाँ 6s है तो यहाँ 7s हो जाएगा, यहाँ 6d आ जाएगा, यहाँ 7p आ जाएगा, और यहाँ 5f आ जाएगा, ठीक। सेम 6 की जगह ये होगा। and these seventh period will mainly contain radioactive elements which are man-made, ठीक है। now the periodic table will end at the atomic number 118 and which belongs to noble gas family, ठीक है। अच्छा, 5f एलिमेंट्स वालों को भी वी कॉल देम इनर ट्रांजिशन एलिमेंट्स, क्योंकि उसमें 5f फिल हो रहा है, ठीक है। सो 5f and 4f were called inner transition series, lanthanoids and actinoids respectively, ठीक। तो 4f और 5f were inner transition elements and they are placed separately below the periodic table to maintain its structure and to preserve the classification by keeping the elements with similar properties in singular column। क्यों, देखो दो रीजंस हैं। पहले तो टू प्रिजर्व द स्ट्रक्चर ऑफ पीरियोडिक टेबल, दूसरा अगर हम इनको इफ वी डोंट प्लेस दीज एलिमेंट्स बिलो द पीरियोडिक टेबल, तो यहाँ पे जो सिमिलैरिटी आ रही है ना, इट विल गेट डिस्टर्ब। सो इन ड्यू टू दीज टू रीजंस the actinoid and the lanthanoid series are placed below the periodic table, the question can be asked, why are lanthanoid series and actinoid series placed below the periodic table? So there are two reasons. First is that to maintain the structure and second is the to preserve the classification of elements। तो हमने क्या क्लासिफाई किया है कि सेम प्रॉपर्टीज वाले एलिमेंट्स आर बिलो इट कैसे, अभी व्हेन यू स्टडी मेटल्स, मेटलॉइड्स एंड नॉन मेटलॉइड्स, तो आप देखोगे कि मेटल्स वाले सारे एक साथ हैं, मेटलॉइड्स सारे एक साथ, नॉन मेटल्स सारे एक साथ, To preserve this thing also, these actinoids and lanthanoids are placed below the periodic table. Okay. So abhi tak what we have studied electronic configuration along the period. Iske baad the topic is to study the electronic configuration along the group. So period tak, is it clear?
Yes, ma'am.
Okay. Let's move to the group-wise electronic configuration. So, elements in the same vertical column or group have same valence shell. कैसे? देखो, all these elements, group one वाले elements की अगर हम बात करें, so you'll see all these elements will have S as their valence shell. ठीक है, इसमें 1s होगा, इसमें 2s होगा, इसमें 3s होगा, it will have 4s, it will have 5s, it will have 6s, and it will have 7s. So you'll see that the vertical column or group will have valence shell electronic configuration same. ठीक है, so इससे क्या होगा, उससे their properties will be similar. Outer orbital जो है it will be same, so उससे properties will be similar. ठीक है, ns orbital will be same. For देखो 1s, if I'm talking about group 1, तो group 1 के लिए I can say that the electronic configuration for group 1 will be ns1. For group 2 I can say the electronic configuration will be ns2. ठीक है, ऐसे ही इसके लिए I can say it will be np1. इसके लिए I can say np2, इसके लिए np3. ठीक है, so this will be the electronic configuration of groups के लिए होती उतना हमें पढ़ने की जरूरत नहीं. इट इज वेरी इजी कि जो वर्टिकल कॉलम्स है सब में ns, इसका 2s, इसका 3s, इसका 4s, इसका 5s, 6s इज नॉट वेरी डिफिकल्ट. ठीक है, तो ग्रुप वाइज इलेक्ट्रॉनिक कॉन्फ़िगरेशन इज नॉट वेरी मच नीडेड. अच्छा, now we have classified our periodic table into groups and columns. Now we will study the electronic configuration. We'll study the electronic configuration according to blocks. Okay. Now whatever the valence shell will be, we'll classify those elements into blocks. For example, अगर valence shell S है, so we'll classify them into S block. If the valence shell is P, we'll classify them into P block. If the valence shell is D, we'll classify them into D block, and if it is F, we'll say it is F block. Okay. Let us see a more clear थोड़ा सा. The above principle and the electronic configuration of atom provides a theoretical foundation of periodic classification. ठीक है, तो above principle जो हमने पीछे पढ़ा था, it provides a periodic theoretical classification. The elements in the vertical column of the periodic table constitute a group or a family that exhibit a similar chemical behavior. So जो group की बात हो रही है, now if I'm saying if I'm saying about a group, so इस group के जो भी elements होंगे, they'll have same chemical behavior. ठीक है, इस group के जो भी elements होंगे, उनका same chemical behavior होगा. Now we know that the chemical behavior is based on the number of electrons. कितने electron present है outermost shell में? We can say कि outermost orbital में जो भी electron present है, उसी पे chemical behavior डिपेंड करता है. तो इसीलिए ग्रुप 1 के जो भी एलिमेंट्स होंगे, they'll have one electron in their outermost shell. ठीक है, okay. Now we'll classify the elements into 4 blocks. What are those 4 blocks? Those 4 blocks are S, P, D, and F block. ठीक है, how are we classifying the elements into blocks? S, P, D, and F block. What is the basis? The basis of classification in block is type of atomic orbital. Okay, type of atomic orbital that are filled with electrons. Okay, the atomic orbital, the valence shell, the last electron, the last shell में how much electron is there, yeah, the last electron goes in which atomic orbital. We are classifying the blocks on the basis of this. Okay, we have 2 exceptions. Which are these exceptions? Hydrogen and helium. ठीक है, helium को we are setting helium into P block Why are we saying it into P block, though it has classification as 1s2? Because it is fully filled. It shows the similarity of noble gas, इसीलिए इसको we have kept them into noble gas classification. ठीक है, तो we have you can say we have ignored its that property ki the outer electron is going into which shell. We are ignoring that property. We are going its chemical properties, and it is showing its chemical properties as noble gases. ठीक है. And if we talk about hydrogen, तो hydrogen का 1s1. Okay, now hydrogen can easily lose one electron and go into the uh, noble gas arrangement, but it can easily, like हाइड्रोजन के पास एक इलेक्ट्रॉन है, एक इलेक्ट्रॉन लूज करना तो बहुत इजी है. It can easily lose one electron and go into the hydrogen family, but so go in the you can say noble gas family. But hydrogen is a special case and it is placed at the top of the periodic table. ठीक है. So अभी तक whatever the you can say demerit या whatever एक जो गलती मिली है periodic table में, that is uncertainty of position of hydrogen. ठीक है, उसके अलावा none of the you can say demerits have been found in the modern periodic table. ठीक है. अच्छा, हाइड्रोजन के बारे में क्या है प्रॉब्लम, कैसी प्रॉब्लम है, दिस विल स्टडी इन आगे की चैप्टर्स. ठीक है, अभी इसमें इसको डिस्कस करना जरूरी नहीं है. अभी वी आर ओनली डिस्कसिंग कि हाउ आर वी क्लासिफाइंग द ब्लॉक्स. वी आर क्लासिफाइंग द ब्लॉक्स ऑन द बेसिस ऑफ which the outermost the valence shell electron is going into which shell. In that we have two exception, hydrogen and helium, and uski bhi explanation I have given you. ठीक है. Now more about these elements will be discussed later. अच्छा, अब क्या हो गया, अब हमने क्लासिफाई तो कर लिया. अब वी स्टडी सेपरेटली एस ब्लॉक, पी ब्लॉक, डी ब्लॉक और एफ ब्लॉक को हम लोग सेपरेटली पढ़ेंगे. ठीक है. नाउ लेट अस मूव टू एस पी एंड डी ब्लॉक. सबसे पहले लेट अस स्टडी एस ब्लॉक. Okay, now the elements of group 1 and group 2 belong to S block. ठीक है, तो group 1 is this one. Group 1 is this one and group 2 is this one. ठीक है, so they belong to uh, S block. Group 1 is called alkali metals and group 2 are called alkaline earth metals. ठीक है, and they have electronic configuration as NS1 and NS2. ठीक. Got it? Clear? Electronic configuration 1s1 and 1s2 होगा. Since their outermost shell is S, so they are classified as S block element. अच्छा, they what now what are the properties of these elements? Overall properties पढ़ते हैं. They are metals. And which type of metal? Reactive metals. Okay, so these are S block elements are reactive metals. ठीक. अच्छा, also they have low ionization enthalpy. What is ionization enthalpy? Ionization enthalpy is energy needed for an element to lose its electron. ठीक है, so since they have only one electron or two electron in their outermost shell, they can very easily lose one electron or they can very easily lose two electrons to form ion. ठीक. So these elements, S block elements की अगर बात करें तो S block elements में we know that they are reactive metal and also they have low ionization energy. Ionization energy क्या होती है? Let me write it here. Energy needed to form ion. ठीक. They can easily lose electron and form ions. ठीक है, इसीलिए they are called metals. They are highly reactive metal because they can easily do. अच्छा, now अभी we said that they are metals, तो metallic character होगा. Now as we move down the group, metallic character increases. ठीक है, as we go down the group, इसका भी रीजन है, अभी आई एक्सप्लेन. मेटालिक कैरेक्टर इंक्रीज. अच्छा, if I'm telling you कि something is metal, तो chemistry के basis पे how can you say something is metal? Metals can easily lose electron, right? Right, Sam? If I'm saying कि something is metal, so you will basically say कि it can easily lose electron, that's why it is metal, right? अच्छा, now if I am saying कि as we move down the group metallic character increases, तो उससे क्या मतलब होता है? सी, अगर हम फर्स्ट पीरियड की बात करें तो फर्स्ट पीरियड में we'll have 1s1, then we'll have 2s1, then we'll have 3s1, then we'll have 4s1, 5s1, 6s1, 7s1. As we are moving down the group, distance from the nucleus of the electrons is increasing. वाई? क्योंकि देखो 4s से पहले 3p रहा होगा, 3s रहा होगा, 2p रहा होगा, 2s रहा होगा, 1s रहा होगा. So the distance from the nucleus of this particular electron is increasing. और जैसे जैसे distance बढ़ेगा, it is very easy to remove the electron, right? क्योंकि इलेक्ट्रॉन जितना ज्यादा इलेक्ट्रॉनिक चार्ज कम होगा, जितना ज्यादा फोर्स ऑफ अट्रैक्शन कम होगा, उतनी आसानी से वी कैन रिमूव द इलेक्ट्रॉन. और जैसे जैसे हम नीचे आएंगे, एज विल मूव डाउन द ग्रुप, वी विल सी द डिस्टेंस बिटवीन द न्यूट्रॉन, distance between the proton and the electron, or you can say distance between the nucleus and the electron is increasing. So it can easily, the electron can easily be removed. और जितना easily electron remove हो जाएगा, उतना ज्यादा metallic character. तो इसीलिए it is said that as we go down the group, the metallic character increases. ठीक है?
Yes, ma'am.
Yes. Now, because of high reactivity, they can never found in pure state. Since they are very reactive, so S block वाले elements को they can never be found in pure states except for lithium and beryllium. Lithium and beryllium are predominantly ionic. ठीक है? Lithium और beryllium को you will mainly found in ionic state, and they can be found in pure state because they are formed in ionic state. ठीक है? So are we clear with S block elements?
Yes.
Okay. Now let us move to P block elements. So P block elements में कौन कौन से आएंगे? P block elements में group 13 से group 18 elements आएंगे, right? So the elements comprising the elements which are there in the group 13 to group 18 form the P block elements. Now एक term आता है representative elements या main group elements. So S block along with P block, the elements in the S block and the P block, they together are called representative elements. ठीक है? तो S block वाले elements along with the P block वाले elements, they are called representative elements or main elements. ठीक है? Okay. Now let us talk. अब हो गई ये बात. Let us talk about P block elements. So general electronic configuration of P block elements will be NS2 NP1 to NS2 NP6. ठीक? So S block element, P block elements का, if you will see the electronic configuration, it will be NS2 2P1 to NS2 2P6. तो यहाँ पे जो भी होंगे उनका NP नहीं, सॉरी NP 2P नहीं, P block की बात कर रहे हैं ना, NP सॉरी N. ठीक है? So if you see boron, तो इसका it will be 2P1. If you see aluminium, 3P1, gallium 4P1, indium 5P1, carbon 2P2, silicon 3P2, germanium 4P2, tin 5P2, right? So it will range from NS2 to fix है NP1 to NP6. ठीक है? Each period. Now if I'm saying about period, तो at the end of each period, ये second period, ये third period, ये fourth, ये fifth, ये sixth और ये seventh. Now at the end of each period in P block you will find a noble gas. ठीक है, हर पीरियड के एंड में इन P block you will find a noble gas. ठीक. अच्छा, नोबल गैस क्या होती है? नोबल गैस आर दोस elements जिनका outermost electron is fully filled and they are very non reactive. वो बहुत स्टेबल होती है. They have very low chemical reactivity. ठीक है. Why they have very low chemical reactivity? Because they are completely filled by electrons. ठीक है, इसमें fully filled होगा. अब fully filled electron remove करना, किसी भी चीज को stable से unstable बनाना is very difficult if they are fully filled. ठीक. So noble gases are completely filled by electron and it is very difficult to alter its stability by addition or removal of electron. ठीक है, the noble gases exhibit very low chemical reactivity. Now before, अब हमने बात कर लिया group 18 elements are called noble gases. ठीक है, before noble gases we have halogens and they are very reactive. ठीक है, group 17 elements are called halogens. Why? क्योंकि उनको बस एक इलेक्ट्रॉन चाहिए टू अटेन नोबल गैस कॉन्फ़िगरेशन. ठीक है, so they are very reactive. And before halogen we have chalcogens. ठीक, तो these are called noble gases, these are called halogens and these are called chalcogens. These two groups of elements are have highly negative electron gain enthalpy. Electron gain enthalpy क्या होता है? The ability to take electron. ठीक है, जितना ज्यादा नेगेटिव होता है उतनी बड़ी वैल्यू होती है. So it can easily, these two electrons, group 16 and group 17 can easily take one electron, and because when they'll take one electron they'll attain noble gas configuration. अगर देखो फ्लोरीन में एक इलेक्ट्रॉन आ जाएगा, it will contain neon वाला configuration फ्लोरीन में, so they have very high electron give enthalpy. ठीक है, very negative electron, negative मतलब देखो हाँ, नेगेटिव इलेक्ट्रॉन गेन एंथैल्पी का मतलब इट कैन इजीली टेक इलेक्ट्रॉन. ठीक है, so it can easily take one or two electron to attain noble gas configuration. ठीक, so group 16 and group 17 elements have highly negative electron gain enthalpy. इलेक्ट्रॉन गेन एंथैल्पी क्या है, आयोनाइजेशन एंथैल्पी क्या है, ये इस चैप्टर के आखिर में एवरीथिंग इज एक्सप्लेन्ड वेरी क्लियरली. ठीक है, डोंट वरी. ओके, नाउ these in the, इसमें जो भी होंगे ना, जो भी एलिमेंट्स होंगे दे आर नॉन मेटल्स एंड नॉन मेटेलिक कैरेक्टर इंक्रीजेस एज वी गो फ्रॉम लेफ्ट टू राइट अक्रॉस अ पीरियड. सो जब हम लेफ्ट टू राइट जाते हैं, बेसिकली लेफ्ट टू राइट का मतलब when we are going like this, so non-metallic character is increasing. Why? Non-metals क्या करते हैं? इलेक्ट्रॉन गेन करते हैं. See, fluorine can easily gain electron, oxygen can easily gain electron, oxygen से ज्यादा easily fluorine can gain electron. इसीलिए as we are moving away, as we are moving left to right in the P block, the non-metallic character is increasing. ठीक है, and metallic character increases as we go down the group. तो ये S block पे भी चल रहा था और ये P block में भी चलेगा कि as we'll go down the group metallic character will increase. ठीक, so are we clear about P block elements? Sam?
Yes, ma'am.
Okay, so after P block elements we are left with D block and F block elements. Okay, so we'll finish these topics today. Okay. D block elements को we call them transition elements. Why were we calling them transition elements? क्योंकि वहाँ पे 3D fill हो रहा था, right? 3D पहले fill हो रहा था, इसलिए we're calling as transition elements. Now D block elements में कौन कौन आएंगे? D block elements में group 3 to 12 आएगा. ठीक है, this group 3 to 12 comprises of the D block elements and they are characterized by filling of d orbital. तो उनका जो outermost orbital होगा that is d orbital and therefore they are referred to as d orbitals. अच्छा, what is the electronic configuration? Electronic configuration will be ns 0 to 2 and n minus 1 d 1 to 10. ठीक, ये हर for every group there is a general electronic configuration and you must remember that. ठीक है. For S block I told you that it will be NS1 or NS2. ठीक है. For P block it will be NS2 NP0 NP1 to 6. ठीक है. For D block it will be N-1D 1 to 10 and NS 0 to 2. ठीक है. We have one exception that is PD palladium जहाँ पे the electronic configuration is 4D10 4D10 5S0 5S0. ठीक है. There is only a one exception for palladium. बाकी all everyone follows this general electronic configuration. ठीक है. Now these S block elements are all metal. ठीक है. These are all metals. अच्छा. They also form colored ions. They impart colors and they exhibit variable oxidation state. तो इनकी properties क्या क्या हो गई? इनकी properties ये हो गई. They are all metals. ठीक है. They impart colored ions होते हैं ये and they exhibit oxidation number. क्या होता है? Oxidation number क्या होता है कि charge जो आएगा वो oxidation number होता है कि how much electron they can take. ठीक है. ऑक्सीडेशन और रिडक्शन अभी भी स्टडी रिडॉक्स में. तो ऑक्सीडेशन स्टेट दे शो वेरिएबल ऑक्सीडेशन स्टेट. अब ऑक्सीडेशन स्टेट क्या होता है दैट आई विल एक्सप्लेन यू इन आगे के चैप्टर्स. ठीक है. तो अभी तक बस इतना समझो कि पी ब्लॉक और डी ब्लॉक एलिमेंट एग्जिबिट वेरिएबल ऑक्सीडेशन स्टेट्स. ठीक है. ऑल्सो दे शो पैरामैग्नेटिज्म. पैरामैग्नेटिज्म क्या होता है? तो पैरामैग्नेटिज्म का मतलब होता है कि these elements are weakly attracted towards the magnetic field. They are not strongly attracted. अच्छा, why are they weakly attracted? Due to their unpaired electron. ठीक है. Due to their unpaired electrons, they are weakly attracted to the magnetic field, so they are called paramagnetism. अच्छा. And what are the characteristics? They are often used as catalyst. ठीक है. Palladium is widely used as catalyst. When you study organic chemistry, you will see कि palladium को बहुत ज़्यादा use किया जाता है catalyst. ठीक. These were the properties of, you can say, D block elements. ठीक. अच्छा, there are some elements such as zinc, cadmium and mercury, Hg. There are some elements जो जिनका electronic configuration different होता है, so they do not show the properties of transition elements. देखो chemistry है, there are exceptions. So in the D block there are exceptions: zinc, cadmium and mercury, जिनका electronic configuration N-1 D10 and NS2 होता है. They do not show the property of transition elements. Why? क्योंकि इनके पास देखो अनपेयर्ड इलेक्ट्रॉन ही नहीं है. अनपेयर्ड इलेक्ट्रॉन नहीं है तो पैरामैग्नेटिज्म नहीं शो करेंगे. ठीक है. और भी प्रॉपर्टीज है दैट दे डू नॉट शो. ठीक. अच्छा, तो ये these were the properties of transition elements. So in this way we can say that transition elements form a bridge. किसके बीच में? Between chemically active S block are very active, very chemically active S block and less active P block elements. ठीक. So इसीलिए they are called transition metal elements. ठीक. Why? Because they are forming a bridge. देखो ये they are very chemically active and they are not that much chemically active. 13 से अगर आप 13-14 की बात करो, 16-17 are very chemically active. 13-14 की बात करो, they are not that much chemically active. And this D block is forming a bridge, right? This is forming a bridge. So that's why it is called transition elements. ठीक. Clear with D block?
Yes, sir.
Okay. Now let us move to final block, that is F block, जिसको inner transition elements कहते हैं. अभी तक हमने क्या पढ़ा? अभी तक हमने पढ़ा S block, P block, representing S block और P block मिलके representative elements या main group elements कहलाते हैं. Then we studied D block which were called transition elements. Then we'll study F block जिसको भी called inner transition elements. ठीक है? अच्छा. The two rows at the bottom of the periodic table जिसको lanthanoids कहते हैं. Lanthanoids यानी कि from atomic number 58 to atomic number 71 and from atomic number 90 to atomic number 103 are called lanthanoids and actinoids respectively. उनका general electronic configuration क्या होता है? The general electronic configuration for these lanthanoids and actinoids are n-2 F 1 to 14 and n minus 1 D 0 to 1 and ns2. So let me write on the fresh page. You can see यहाँ पे F block डालते हैं F block. ठीक है, तो F block elements कौन कौन से होते हैं? Z is equals to 58 to Z is equals to 71. These are called lanthanoids. And Z is equals to 90 to Z is equals to 103 जिसको हम actinoids कहते हैं. ठीक है, these are said as inner transition elements, lanthanoids और actinoids. और उनका general electronic configuration क्या है? n-2 F 1 to 14 n-1 D 0 to 1 and ns2. So this is the general electronic configuration for F block elements. The last electron added to each element is the F block. जो आखिरी electron होगा, it will be added to the F block. ठीक? Now these two elements are called inner transition elements या F block elements, and they are all metals. ठीक? With each series, the property of the elements are quite similar. हर series की जो properties हैं, यहाँ पे जो starting की properties हैं, they are quite similar. ठीक? Lanthanoids properties will be similar to each other. Actinoids properties will be similar to each other. ठीक? The chemistry of early actinoids is more complicated than corresponding lanthanoids. See, अगर आप actinoids और lanthanoids में compare करो, तो actinoids की जो chemistry है, starting वाले actinoids की जो chemistry है, that is more complex as compared to lanthanoids. ठीक? So the chemistry of is not very much important thing. Lanthanoids properties जो है वो easy है, actinoids property मुश्किल है. क्यों? क्योंकि एक्टिनोइड्स शो अ लार्ज वेरिएबल ऑक्सीडेशन स्टेट. ऑक्सीडेशन स्टेट क्या होता है कि किस चार्ज में वो एग्जिस्ट करेंगे. ठीक है, एंड आल्सो एक्टिनोइड्स आर रेडियो एक्टिव एलिमेंट्स. ठीक, अच्छा. Many of the actinoids, अगर हम बात करें एनसीईआरटी की लाइन की, तो द एनसीईआरटी सेज many of the actinoids in nanogram quantities. nanogram quantities यानी 10 raised to the power -9 की बात हो रही है इन nanogram quantities, और उससे भी कम वैल्यू में they take part in the you can say कौन सी केमिस्ट्री में, न्यूक्लियर रिएक्शंस में. ठीक है, so actinoids in nanograms and also less than nanogram, they take part in nuclear reactions, and so they are called transuranium element. Uranium is the radioactive element. ठीक है, also अभी तक actinoids की सारी property is not fully studied. The studies are still making, studies are still going on actinoids. ठीक है, so these were the uh, properties of all the groups, similar groups. ठीक है, अच्छा, let us see a question जो एनसीईआरटी में भी दिया हुआ है. एक एलिमेंट है Z is equals to 117 and Z is equals to 120. अभी तक it is not discovered. ठीक है, the question is asking if you will do electronic configuration of these two elements, so in which family or in which group you will place these elements. ठीक है, अच्छा, if you see 117 का electronic configuration, it will come out to be Rn. 117 को कैसे करोगे, प्रैक्टिस करनी पड़ेगी आपको, तो समझ में आएगा. ठीक है, when you will see the periodic table very clearly, तो आप देखोगे 117 कहाँ पे आएगा. सी 117 will somehow come here. ठीक, 118 से थोड़ा पहले, तो it will basically come out in halogens. ठीक, और 120 कहाँ आएगा, 120 will come out into F block. नहीं, F block में आएगा 120. 120 आगे जाएगा तो 120 आएगा 18 19 20 आई थिंक 120 जो आएगा वो एस ब्लॉक में आएगा और नए पीरियड बनाना पड़ेगा ठीक है अल्कलाइन अर्थ में आएगा 8s में okay this was the NCERT problem which I was discussing ठीक है so S block P block F block and D block we have studied this S block में there were highly high metal characteristics P block में there were starting was जो group 13 14 वाले हैं they are less chemically active group 16 and 17 are very chemically active then we have P block D block D block are transition element because they form a transition between S block which are very chemically active to P block which are less chemically active starting वाले P block 13 and 14 then we have F block inner transition elements उसमें फिलिंग जो होती है F block पे F में होती है F जो है वो 4F में हो रही है ना 4F में हो रही है इसीलिए they are called inner transition ठीक so these were all about the groups and we can say periods and blocks इसके बाद वाला topic is metalloids non-metal and metalloids उसके बाद we have one two three अच्छा इसके बाद only a few topics left I think